Hello everyone. I am Vikashini, lecturer of Computer Science, SF, Sita Lakshmi Ramaswamy College, Trichy. My topic is about the introduction of operating system. Operating system is a system software that manages computer hardware, software resources and provide common services for computer programs. Operating system is a intermediary between the user and the computer hardware. It allows user to interact with the device and running application. It is a collection of programs designed to manage the system resources. The system resources namely memory management system, processor management system, device management system and then the information management system. It consists of every file, every devices, every section of the main memory and every nanoseconds processing time it's controlled who can use to the system. So this is the system, the user, application, operating system and then the hardware. The operating system is a boss of all computer systems. The example of operating systems are Microsoft, Windows, Mac, Android and iOS. So, the operating system acts as a resource manager. It is a collection of programs designed to manage the system resources, namely memory management system, processor management system, device management system and then the information management system. View the operating system as a resource manager. Each manager must to do the following like keep track of the resources, enforce policy, determine who get what, when and how much, allocate the resources and then reclaim the resources. So memory management system. Memory management system track the resources, memory, what part are in use and by whom, what part are not in use called the free. If multi-programming decide which process gets memory, when it get it and how much. Allocate the resources, memory, when the process requests it and then reclaim the resources, memory, it's in the process no longer needs it or it can be terminated. Next, processor management function. Processor management function track the resources, processor and then the status of the processor. The program that does this has been called the traffic controller. If multi-programming decides which process gets the processor, when and how much, this is called the process scheduler. Allocate the resources to the processor to a process by setting up necessary hardware registers, the dispatcher. The processor usage terminates, that does not allow the amount of usage, so it's the reclaimer of the resources, processor. Device management function keep track of the resources, device, channels and then control units. This is typically called as the I/O traffic controller. Decide what is an efficient way to allocate the resource device. If it is to be shared, then decide who gets it, then it's called the I/O scheduling. Allocate the resources, device, they initiate the I/O operation. Reclaim the resources, the I/O terminates automatically. So, the last resource manager, information management system. Keep track of the resources, information, its location, use, status, etc. Decide who gets use of the resources, enforce protection requirements and provide accessing routine lines. Allocate the resources information, example, open a file and then close a file is called as the deallocate the resources. Next topic is about an operating system process viewpoint. An operating system consisted of a collection of programs to manage resources. The process 1, process 2, process 3 operating system. This is the structure of process viewpoint. Multi-processes is in a multi-programmed system. An operating system process viewpoint, the life cycle of a process can be represented 3 states: run state, wait state, ready state. Run state, the process has been assigned a processor and its program are presently being executed. Wait state, the process is waiting for some event. Ready state, the process is ready to run but there are more processors than process and it must wait for its turn on a processor. So this is the simple states of the processor: run state, ready state, wait state. Run state, process assigned to the processor and then the wait state, process must wait for I/O completion. Ready state, I/O has been completed. So this is the model of process state. The user submit a job to the system. The system hold the job and then we go to the ready state and the process can be run, and then almost all the states are completed, then it states to the complete state. The submit state. A user submits a job to the system. The system must respond to the user request. Hold state. The user job has been converted into internal machine readable form, but no resources has been assigned to the process. Complete state. The process has completed its computation and all its assigned resources may be reclaimed. So, model of process state. First, the user submits his job to the system. Submit state. The spooling routine reads the job and place it onto a disk is the hold state. In picking a job, a scheduler called memory management to determine if sufficient main memory is available, and call device management to determine whether device requested by the job are available. The job scheduler determines the device requirement for the user job cards. The job scheduler decides that the job is to be assigned resources. The traffic controller is called to create the associate process information, and memory management is allocated to the necessary main storage. The job is then loaded into memory, and then the process is ready to run is called a ready state. The ready to run is called as a ready state. When a processor becomes free, the process scheduler scans the list of ready process, chooses a process and assign to a processor is to the running state. Device management would initiate the IO operation and then call process management to indicate that the process requesting the file is awaiting the completion of IO operation is the wait state. If the process should complete its computation, when it's run again, then it pays into the completed state and all allocated resources are freed. Complete state. So this is the overall state of processing management. Thank you.